All right, let's go ahead and begin. First off, welcome to the second installment of our webinar series on picking technologies improving order fulfillment. I'm Stephanie Hardy, and I'll be your moderator for today's webinar on behalf of Bastion Solutions. Bastion Solutions is a global material handling system integrator dedicated to helping customers increase productivity in their distribution and manufacturing facilities. For those of you who were unable to join us for part one of our series, we covered some basic picking technologies such as pick and put to light, voice-directed picking and RF, as well as carousels and vertical lift modules. Today we'll be diving into more advanced goods-to-man picking technologies. As you can see on the agenda, we will start off with a brief introduction of today's presenters, provide a quick recap of our presentation on basic forms of order picking, and then Marvin will lead us through an overview of popular goods-to-man technologies. Following the presentation, we'll finish up with a quick Q&A session. Your presenters for today's webinar are Eric Cameron, Vice President of Software Sales at Bastion Solutions, and Marvin Logan, Director of Consulting Services at Bastion. Eric and Marvin will be available after the presentation to answer questions, so please submit any questions you might have via the question box in the GoToWebinar panel to your right. You can also use it to let us know if you're experiencing any technical issues. Thank you everyone for joining us, and without further ado, I'll turn it over to Eric Cameron to get us started.
All right, thanks, Stephanie. As a recap to part one of our series, we're going to take a moment to review the top trends that are affecting distribution operations and how they are affecting picking technologies today. The first major trend we're going to talk about is really uncertainty. Uncertainty over government operations and policies, tax policies, and questions about the future of the overall economy have put many companies in a holding pattern for investments in their supply chain, even when presented with solutions that have very good ROIs. The second major trend is the fact that there is a generational shift taking place in a lot of different workforces. As millennials are taking hold in many companies, companies are having to reevaluate what it takes to keep these employees engaged and motivated within their organizations. The use of advanced technologies in many applications can play a key role in an employee's job satisfaction and their overall performance. Increases in e-commerce have greatly impacted overall distribution as well, as companies have had to change how they reach their customers. Companies have also had to rethink their supply chains to meet the near real-time delivery demands of their clients. In the same vein, not only do customers want things faster, but they require greater selection, causing an increase of SKUs in many industries. This means more to manage within your existing supply chain. Data capture needs in many industries are continually driving changes in order fulfillment as well. For example, lot number and serialization within e-commerce and e-pedigree initiatives for pharmaceutical markets can present significant challenges that picking technologies can help us address. All of these factors lead to the need for companies to design operations that deliver a more productive workforce without sacrificing the safety and ergonomic concerns that can ultimately cause companies more cost in their operations. Over time, customer expectations have evolved also, and along with them, the technology needed to meet new order fulfillment demands. Early in the 1700s to 1800s, deliveries to homes could take months as people waited for the traveling peddler to arrive with their wares. But as retail markets have developed, so have the technologies that have been used to support it. In the 1960s to about the 1980s, many of the common technologies that we still use today, including conveyor sortation, automated storage, and information systems focusing on improving the supply chain, came onto the scene to help meet the maturing retail fulfillment requirements. With the advent of the internet and e-commerce, new technologies have also emerged to deliver smaller orders directly to consumers more frequently. To manage this ever-changing landscape, in the first part of our series, we looked at a number of different types of picking technologies and compared them to each other to help convey the possible applications for each. We started by looking at solutions where operators travel to where the product is stored for processing. This included paper and label-based picking systems. We also talked about mobile-based solutions where we used RF or mobile computers for scanning applications, and also looked at voice-based applications. We also looked at different light-directed technologies, including pick-to-light and put-to-light technologies. From there, we moved to more traditional goods-to-man technologies to see how they stacked up against their manual picking counterparts. In part one, we talked about horizontal carousels, vertical carousels, and vertical lift modules. Our evaluation covered many aspects of each of these technologies, including typical applications for each, along with their strengths and their weaknesses. Ultimately, it gave us an overall view of these applications, and we created a technology matrix that helped us showcase the productivity and accuracy capabilities of each one. While this chart can give us a data point to consider while helping us to see what these technologies can do for you and your business, it's not intended to be a single point of decision making. In today's webinar, we're going to delve into some more advanced technologies and look at their applications. We're going to be looking at some advanced man's-to-good picking, more advanced goods-to-man technologies, and some fully automated picking solutions. We've included these in our matrix for comparison purposes, but their performances can vary wildly based upon how they are used, as you can see in this chart. That being said, these technologies, while coming with typically a higher price tag, can provide really the greatest efficiencies available in the market today if used in the correct application. Today we'll be looking at, again, having the picker travel to the product. We'll be looking at some advanced solutions using AGVs or automated guided vehicles, and we'll be looking at picking using augmented reality. We will be looking at some more advanced goods-to-man technologies, including some advancements in shuttle-based systems, in addition to mobile picking robots. And then finally, on the automated picking solutions, we'll be talking about a couple different solutions, both for each picking and for case picking. I'm now going to transition over to Marvin. He's going to take us through these technologies.
Thanks, Eric. So we're going to go through some technologies here. First of all, it's an interesting use of technology that's been around for a while to move pallets. Is now being used to fulfill orders in a tour picking environment. This is Pick and Go by Cole Morgan. Pick and Go takes an ordinary order picker like a Crown or a Raymond, for example, and turns it into an automated guided vehicle or AGV. When combined with a pick-to-voice system, this concept can improve picking productivity by 60 to 100%. It does this by allowing the operator to pick without having to climb off and on his vehicle. The AGV follows the picker from pick location to pick location, even knowing the pallet height for improved ergonomics. The system even knows when the pallet is full and calls for another unit to come so that the picker can stay in the picking area. The finished pallet can then be taken by the AGV to the shipping area to be automatically wrapped. Another feature of the system is that the vehicle never really loses its ability to be used as a manual piece of equipment if needed. As voice technology has improved, so has the ability for systems to use vision as a mean of communicating information to pickers. One example is Keysoft by Knapp. Keysoft Vision is a paperless picking technology that functions with augmented reality. Augmented reality is virtual information and images merging with the real environment. The employee wears a special picking headset with a see-through display on which all the relevant information for the picking process is superimposed. The navigation system provides accurate guidance along the shortest distance from storage location to storage location. The integrated camera with image processing can also capture serial numbers and lot IDs and things like that. Both of the employee's hands are free for picking. This is a relatively new tool, and it's likely to find its place in the mix of picking-assisted technology. Traditional automated storage and retrieval systems, or ASRS, have consisted of single cranes servicing an aisle of storage. So throughput of the cranes was really tightly linked with the amount of cases or totes that were in the storage aisle. Shuttle systems have decoupled the need for this association by providing multiple retrieval units that can service multiple levels and even multiple storage aisles. Often there are lifts in front of the aisles that can move the shuttles between levels and transfer devices to move the shuttles between aisles. Shuttle systems have become more prolific over the past several years, and they are available from several equipment manufacturers, each with varying capabilities. They can be part of a goods-to-man system delivering totes of product to ergonomic pick stations. First announced in 2001, Kiva was one of the first mobile robotic systems that decoupled storage from retrieval in an attempt to create a highly scalable and flexible picking system. Product is stored in shelving units, or pods as they're called, and delivered to picking stations by autonomous mobile robots. The robots use a combination of tracking and dead reckoning by 2D barcode positions in their movement paths. The Kiva software manages the pod to station delivery process in order to maximize pick rates. It also manages the location of the inventory pods to keep the pods with the fastest moving inventory closest to the pick stations. Kiva has been criticized as being a horizontal system, taking up floor space versus vertical space. However, the company states that it can put Kiva pods on mezzanines and use lifts to raise and lower their robots. It may also be a good solution for older buildings since floor conditions and lighting are not as important compared to other systems. As it was growing in acceptance in the U.S. as a good e-commerce solution, Kiva made headlines last year when it was purchased by Amazon for over $700 million. Another goods-to-person system is AutoStore. AutoStore is from Hatland, a company in Norway. It uses totes to store product in silos or stacks in a grid. The retrieval robotic units travel on the grid and obtain the totes from openings at the top. You can see in the video here that a unit is digging for a tote that is 5 totes down in the stack. As it retrieves a tote that is on top of the one that it needs, it stages it on top of the grid. When it has the tote that is needed, it takes it to a pick station around the perimeter of the grid. Meanwhile, another bot comes by and cleans up by putting back the unneeded totes. In this way, the system tends to self-profile. The totes that are needed most often tend to stay near the top of the grid and are more quickly retrieved. Slower moving totes migrate to the bottom of the stacks on the grid. Because the inventory in the totes that are stacked on top of each other without any racking, AutoStore uses the cube of a warehouse extremely well. It is also a highly scalable solution with the ability to easily add additional tote stacks for storage and robots for throughput. The picking stations can deliver up to 500 totes per hour to an operator. Another new goods-to-person technology is Perfect Pick by OPEX. This system also uses autonomous shuttle carriers called ibots to move totes or trays to picking stations at either end of an aisle. Unlike other shuttle technology that must rely on elevators, conveyors, or lifts, ibots pick and stock inventory on both sides of the aisle, delivering totes in sequence directly to a picking station. The ibots can deliver totes at the rate of 800 to 1,000 cycles per hour. They also operate on the principle of redundancy, so Perfect Pick has no single point of failure. An extremely compelling feature of this technology is the inherent scalability it provides. Users can scale a Perfect Pick system's throughput capacity by adding additional ibots as needed to support processing. This allows for a lower initial investment to install the technology with a good level of flexibility for future growth. Another neat feature is that the ultracapacitor-powered ibots charge as they are moving horizontally in the aisle, and they recapture regenerated energy as they lower themselves. A-frames have been the workhorse of the pharmaceutical industry for some time. But it's interesting that an entire industry has come to rely on A-frame technology, but it's virtually unused in other distribution industries. Its strengths there are the most obvious, as there's a relatively small and uniform product size, and that makes it ideal for a picking solution. A single A-frame can pick 50,000 products an hour and can handle 10 to 20% of a pharmaceutical DC SKUs. A-frames dispense products stored in long chutes. The dispensing mechanism, located at the bottom of each chute, pushes the lowermost article onto a conveyor belt. This happens at an incredible speed of up to 4 units per second. The chutes are positioned on each side of the conveyor belt, leaning backwards over the belt. Seen from the front, these skewed chutes and the conveyor belt below form a giant A, giving the A-frame its name. The control system divides the conveyor belt into logical sections, one section for each shipping order. At the end of an A-frame system, there are small clusters of products on the conveyor belt. Each cluster represents a shipping order. This is usually followed by some sort of automated packaging. The system still has to be replenished, but that labor typically is just a fraction of the picking labor that's saved. The product profile must be right, but A-frames could have a role in many automated picking opportunities. Robopick is a fully automatic, fast and precise picking cell that can integrate into existing warehouses and achieve up to 2,400 picks per hour. The two-step imaging process system automatically recognizes the position of products and controls a delta picking robot, therefore removing the need to enter individual product characteristics and features or to arrange products in a particular position. Product can be delivered automatically from a mini-load or other automated system. Robopick uses a combination of 3D and 2D picture processing. In a matter of seconds, the picture processing cell identifies 4 to 6 pickable products as the product tote passes by. The picture processing is not affected by products in several layers or inclined position, jet black articles, round products, or asymmetric or beveled packages. The system then chooses the product that the robot will pick and deposits it into a staging lanes that are released to outbound totes. If the order profile warrants, robots can be used economically to pick layers off of cases off of pallets and then simulated on a conveyor system. With rates of 120 to 240 layers per hour, this can generate a lot of case picks with little or no human intervention. Pick cases can either go directly to a shipping sortation system, or they may replenish a case dispenser for future order fulfillment. We'll talk about case dispensing here in a later slide. This is Schaefer's case picking system. The system uses pallets that were stored in a unit load ASRS. The pallets are delayered by a robot, and then the layers of product are stored in a layer storage ASRS on trays. When product is needed to build a mixed pallet for an order, the layers are taken out of storage and cases are released from the layers. Using a device called a case wheeler, the needed cases are conveyed off of trays and onto a conveyor to be sent to a robot palletizing area. The software pre-plans the way the pallet will be built so that the cases are presented to the robot in the correct sequence. As the robot builds the pallet, it is lowered through the floor and wrapped for stability. No humans touch the product from the time the full pallets are received to the time the finished pallets are shipped. InnoPick is a brand new technology from DRL, a company in Montreal. Cases of product are inducted into the InnoPick system, either in layers for fast-moving product or single cases for slower-moving product. InnoPick introduces cases to its buffer storage by moving them on a padded chain conveyor that moves in a heartbeat every 2 seconds. The cases then move into storage, again on padded chains. When product is needed, it moves out of the storage onto the same chain conveyor that was used for induction. So inbound cases come in on one side of the system and mixed cases for an order come out on the other side. This system is very compact and multiple layers can be stacked on top of each other. It is also very simple and thus less expensive than other technologies used for the same purpose. Each InnoPick level can process up to 1,800 cases per hour, with multiple levels handling tens of thousands of cases per hour. When coupled with robotic delayering and palletizing system, this technology can be used to pick and palletize orders with minimal human intervention. One of the newest mobile robotic systems is Symbotic's Matrix Select. This system uses mobile autonomous robots like Kiva or Perfect Pick, but in a racking matrix designed to store individual cases of product. The system's robots have 100% access to any case in the system, allowing the system to be very robust compared to traditional mini-load crane systems. It's also scalable by adding additional storage capacity or more rovers for additional throughput. Replenishment can also be an issue for high-demand picking systems. Prepare and replenishment cartons for an each picking operation, whether in a traditional or a goods-to-person operation, can be improved by automating the opening of cases prior to put away. The system shown uses a set of high-speed robotic knives to slit the 4 sides of cartons on the fly. At speeds of 1,300 cartons per hour, adopters of the technology have seen payback in 6 to 12 months. Productivity in a picking operation, especially in a goods-to-person operation, is highly tied to ergonomics. General principles include presenting product totes or cases at a level that provides optimum operator comfort and to avoid stress or injury. The operator should not have to stoop or bend. Human interfaces to computer screens should be at eye level. The use of lights or indicators should guide the operator to the put location. With a properly designed system, high performance rates approaching 1,000 picks per hour are possible. Along with the increased demand for throughput, there has been growing needs for quality, traceability, and data capture in the picking process. Traditional systems often meet these needs by having the operator scan additional product information like UPCs or serial numbers during the picking process. But this can slow pickers down and is not 100% error-free. Automatic order verification aims to improve this situation by automatically verifying picked product prior to shipping. Picked product is inducted into the system, and then a series of stranded conveyor belts simulates them. The product is identified by camera scans and barcodes, and product serial numbers are captured if needed. The captured images can also be stored to retain this information about the picked order. Once verified, the contents are put back into a tote to continue to the shipping operation. The standard system can handle approximately 6,000 units per hour. In this and in the last webinar, we've been exploring available technologies that have a tremendous impact on the picking operations of a distribution center. In many situations, traditional, more basic systems such as mobile, lights, or voice can add a lot of value to the operation. Today, we talked about advanced solutions including goods-to-person, shuttles, and robotics. However, the choice of the right technology includes evaluating many factors. These include throughput requirements, order and SKU profiles, the cost of labor, and even the company's financial policies and risk tolerance. We at BASH would welcome the opportunity to explore these factors with you and recommend the right solutions for your operation.
All right, thank you, Marvin. That concludes our presentation for today, but it does look like we have just a few questions here from the audience as we transition into our Q&A session. The first is from Tim. He said, you said the Knap Vision picking system is new. Has it been installed anywhere yet? If so, what kind of pick rates is it getting?
Yeah, that's a good question. It is a very new technology. There's one live installation in Russia, and potentially others that are being planned here for the U.S. as well. Because it's so new, we really don't have any information on pick rates. But I believe that this technology, with especially Google's going to be releasing Google Glass next year. I think we're just going to see this technology really explode and come in other forms as well.
All right, thank you, Marvin. Our second question is from Deb, and she was asking, what type of information systems come with these technologies, and how can I integrate with my existing software?
Yeah, this is Eric speaking. That's a good question. So many of the technologies that we've talked about today will come with their own software package to control the machine or the process. So those packages from the manufacturer can very often integrate directly with a warehouse management system or ERP system to aid the customer. They'll generally will be very flexible in types of the communication protocols that they can speak back and forth on. Very often, though, what we find is that customers will actually get involved in a third-party piece of software called a warehouse control system that may help them integrate multiple pieces of technology. So in a scenario like where you may have an ASRS, and then you also may have some pick-to-light or pick-to-voice systems. A lot of times the warehouse control system plays as a kind of a flight coordinator and manages the communications between the automation on the floor and the higher level information system like the WMS. So it's very dependent on the application, but there's a lot of different ways that customer can do it.
Thank you, Eric. Our next question is from Michael, and he says, I've seen A-frames used for small items like pharma or maybe CDs or DVDs, but are there larger book handling applications in use that you are aware of?
I would say the traditional A-frame used for, you mentioned pharma or CDs, a lot of that has to do with the ability for the product to withstand the dispensing process. And books and other products that need that more gentle touch don't really do very well in a dispensing type application. So I have not seen it. I'm not aware of it. I'm not saying it doesn't exist, but I do have some background in book distribution, and I have not seen dispensing for books.
Okay, thank you, Marvin. Let's see here. Last question is, are there any live installations of the Haviland Tote Auto Storage Retrieval System in the U.S.?
Yeah, I'll take that. There is one installation in the U.S., but the technology is not really that new. There's about 40 installations in Europe, and we're seeing that it's a newer technology for Bastion to be involved with. But we hope to see additional installations in the U.S. in coming years. We had another question about the AutoStore system. Somebody asked, how does it compare to mini low storage as far as height? And the maximum height of storage for an AutoStore system is 5.4 meters. And then you need another couple meters on top of that for the robots to roam around. So anyway, I think that answers that question.
All right. I think that covers it for all of our questions today. Thank you, everyone, for joining us. If you do have another question that we didn't answer, please feel free to send us an email at info@bastionsolutions.com, and we'll get back to you very soon. Also, please be on the lookout. We'll be sending an email tomorrow with a link to view a recording of today's presentation, as well as a link to download the presentation slides, and then a fact sheet on some of the difference in technology we discussed today. Thank you, everybody, for joining us, and enjoy the rest of your afternoon.